Question 7.37 says, identify the major and minor products that are expected for each of the following reactions. So if we take a look at the first reaction, we have a secondary alkyl halide. We have chloride, which is a weak base / strong nucleophile. So therefore we would predict an SN2 mechanism. Also we have DMSO as our solvent. So DMSO is dimethyl sulfoxide, which is a polar A product solvent, which will even further promote the bimolecular mechanism, so the SN2 reaction. And if you remember, when we do an SN2 reaction on a stereocenter, we should proceed with inversion of configuration, the umbrella flip, if you will. So there is our product. We put the chloride in place of the bromide in the substitution, and we invert the stereocenter. If we take a look at the second question, we have a tertiary alkyl halide. We have a strong base / strong nucleophile, so therefore we should get the E2 product. And since hydroxide is a non-hindered base, that means that preferentially it should form the Zaitsev product or the more substituted product. I'm going to draw in the proton that would be abstracted for the Zaitsev product, and then we have two methyl groups, and the beta protons here, if one of those is abstracted, that will give us the Hofmann product, which in this case would be the minor product. So if we draw the Zaitsev product first, that would be this, and this would be our major product, the Zaitsev product. And then we're also going to get the Hofmann product, and that will be our minor product, because again, hydroxide is a non-hindered base. So if we take a look at the third reaction, we have again a tertiary alkyl halide. We have a strong base, but this is a hindered base. If you remember, potassium tert butoxide is a hindered base. So I'm going to put here hindered base. So again, it's going to proceed via an E2 mechanism, but this time, since we're dealing with a hindered base, the less sterically hindered beta protons are the ones that are going to be preferentially removed. Therefore, the Hofmann product should be the major product in this case. So if I draw that proton being extracted, in this case, the major product will be the Hofmann product, and the minor product is going to result from this proton. I'll just draw it in here in blue. This proton is more hindered, so our hindered base is going to have a more difficult time removing that proton. So therefore, the Zaitsev product and the minor product would be this one. So this is going to be our minor product.